Hi everyone, I am Pandiraj, Assistant Professor, Department of Mathematics, Kamaraj College of Engineering Technology, Virudhunagar. In this video, we are going to discuss about higher order linear differential equation with the constant coefficients of type 4. Already we discussed type 1, type 2, type 3, and in this video, we are going to discuss about type 4. First, we have the nth order linear differential equation with the constant coefficient of the form a0 d power n y by dx power n plus a1 d power n minus 1 y by dx power n minus 1 plus a2 d power n minus 2 y by dx power n minus 2 plus etc. an into y is equal to f of x. Here the coefficients a0, a1, a2, etc. an are all real numbers and right hand side is a function of x. Is a general nth order linear differential equation with a constant coefficient. The solution of this differential equation consists of two parts. One is complementary function CF and another one is particular integral PI. Therefore, the general solution is y is equal to CF plus PI. That is, to solve this differential equation, we need to find two solutions CF and PI, and the general solution is y is equal to CF plus PI. Right. First, we need to the formula for finding auxiliary equation, that is complementary function. We solve the auxiliary equation, we have the roots. Suppose we have three roots, our three roots may be real and distinct, real and equal and complex. In the first case, our three roots are real and distinct, say m1, m2, m3. In that case, our CF is a into e power m1x plus b into e power m2x plus c into e power m3x. Suppose out of three roots, two roots are equal and one distinct root. In that case, m1 is equal to m2 is equal to m and the third one is m3. Therefore, our CF is ax plus b into e power mx plus c into e power m3x. Suppose our three roots are equal, m1 is equal to, m2 is equal to, m3 is equal to m. In that case, our CF is ax square plus bx plus c into e power mx. Suppose our roots are complex and we have complex roots always occur in pairs of the form alpha plus or minus I beta. Here alpha is a real part and beta is an imaginary part and the third one is a distinct root. In that case, our CF is e power alpha x into a cos beta x plus b sin beta x plus c into e power m3x. This is a formula for finding the complementary function. Next, the formula for particular integral. The particular integral evaluation is always depend upon the function f of x, that is of right hand side function. The right hand side function of the form of exponential e power ax or sin or cos ax or sin ax, or algebraic function ax square plus bx plus c, or product of two case. In type 4, we discuss f of x is of the form of e power ax into g of x. And we have e power ax is an exponential function of the form e power 2x, e power minus 3x, e power 7x, maybe e power 0x. And g of x is either sin or cos functions or an algebraic function. It is of type 4. In that form, our pi is equal to 1 by f of d into e power ax g of x. F of d is an operator form of the given differential equation. If right hand side is a product of two functions, first we replace for e power ax. We put d is equal to d plus a. Therefore, our pi becomes pi is equal to e power ax into 1 by f of d plus a into g of x, since we replace d by d plus a. The remaining it is of either type 2 or type 3. Type 2 is of sin or cos and type 3 is of an algebraic function. That's all. Now, we are going to one problem. Solve d square y by dx square minus 3 dy by dx plus 2y is equal to x into e power 3x. This is of second order linear differential equation with a constant coefficient, and right hand side is x into e power 3x. That is product of 2. Here the denominator of the form a plus b into a minus b. A plus b into a minus b, a square equation for. So a square is minus 1 the whole square, minus b square is 16d square. Numerator is minus 1 plus 4. Our differential here becomes d square is equal to minus 4. So d square is equal to minus 4. Our denominator is minus 1 the whole square plus 1. So minus 16 into d square is minus 4. In numerator we operate cos 2x by minus 1 plus 4d. So minus 1 into cos 2x minus cos 2x plus 4 into d of cos 2x equal to 0. Therefore, our cos 2x plus 4 into d of cos 2x means differentiation of cos 2x. Differentiation of cos 2x is minus sin m. Therefore, m is equal to 1 and m is equal to 2. The 1 and 2 are distinct. So, we say m1 is equal to 1 and m2 is equal to 2. The roots are real and distinct. Therefore, our CF is a into e power x plus b into e power 2x, since m1 is equal to 1 and m2 is equal to 2. Now CF is over. Next, to find PI. Yes, the particular integral is equal to 1 by operator form of the differential equation d square minus 3d plus 2 into e power 3x into x. Already we say that it is of type 4 of the form e power ax into g of x. In that case, first we apply for an exponential function e power ax. So we put the substitution for d. D is equal to d plus a. Here a is equal to 3, therefore d plus 3. Therefore our differential equation becomes, that is pi becomes e power 3x into 1 by d plus 3 the whole square minus 3 into d plus 3 plus 2 of x. That is e power 3x into, it is of the form of a plus b the whole square, a square plus 2ab, 2 into d into 3, 6d plus b square 9 minus 3d minus 9 plus 2 of x. And this becomes e power 3x d square 6d minus 3d plus 3d 9 plus 2, sorry, plus 9 minus 9 cancel plus 2 of x. Since C is available, therefore our solution is not over. Now we apply the type 3 because it is of the form of 1 by f of d of x. So it is of type 3. In type 3 we use the binomial series formula, either 1 plus x the whole power minus 1 or 1 minus x the whole power minus 1. So we take 2 as outside, 2 into 1 plus d square plus 3d divided by 2 of x. Yes. Therefore, our next step is e power 3x, 1 by 2 is constant, 1 plus d square plus 3d divided by 2 the whole power minus 1 of x. Now it is of the form of 1 plus x the whole power minus 1. And we know that 1 plus x the whole power minus 1 is 1 minus x plus x square minus x cube etc. etc. Therefore, this becomes e power 3x divided by 2, 1 minus x of x. Since the formula is 1 plus x the whole power minus 1 is equal to this, here x only available. Therefore, we need one term only. Now, this becomes e power 3x divided by 2, 1 minus of d square by 2 minus of 3d divided by 2 of x. Now we operate x inside, e power 3x divided by 2, 1 into x, x minus d square by 2 of x minus 3 by 2 into d of x. And we know that capital D is d by dx. So d means differentiation with respect to x 1 times, d square means differentiation with respect to x 2 times. Therefore, this becomes e power 3x divided by 2 x minus differentiation of x with respect to x 2 times becomes 0. So 0 minus 3 by 2 differentiation of x with respect to x 1 time is 1. Therefore, this becomes e power 3x divided by 2, the LCM is 2, so 2x minus 3 divided by 2, and hence e power 3x divided by 4 of 2x minus 3. It is our particular integral. Hence our general solution is y is equal to CF plus PI, that is y is equal to a into e power x plus b into e power 2x plus e power 3x divided by 4 into 2x minus 3. Hence our general solution. Now we have one more problem, that is solve d square y by dx square plus 5 into dy by dx plus 4y is equal to e power minus x into sin 2x. Again it is of second order differential equation with the constant coefficient, and right hand side is a product of two function e power minus x into sin 2x, therefore this is of type 4. To solve this differential equation, first we write an operator form, put the substitution capital D is equal to d by dx, therefore this differential equation becomes d square plus 5d plus 4 into y is equal to e power minus x into sin 2x. To find the complementary function, first we write an auxiliary equation by put the substitution capital D is equal to m, and we assume the right hand side function is equal to 0. Therefore our auxiliary equation is m square plus 5m plus 4 is equal to 0. This is of quadratic equation in m. To solve this quadratic equation, we have the factors m plus 1 into m plus 4 is equal to 0, that is m is equal to minus 1 and m is equal to minus 4. These two are distinct, therefore roots are real and distinct. Therefore our CF is a into e power minus x plus b into e power minus 4x, of the form a into e power m1x plus b into e power m2x. Here m1 is equal to minus 1 and m2 is equal to minus 4. Next, to find the particular integral, the particular integral is always depend upon the right hand side function. Here the right hand side function is e power minus x into sin 2x. Therefore our PA is equal to 1 by operator form of differential equation d square plus 5d plus 4 of e power minus x into sin 2x. In type 4, first we apply for an exponential function. Here exponential function is e power minus x, so we replace d is equal to d minus 1. That is our replacement is d by d plus a. Here a is equal to minus 1. Therefore d is equal to d minus 1. Therefore our PI becomes e power minus x into 1 by, we replace d by d minus 1. Therefore d minus 1 the whole square plus 5 into d minus 1 plus 4 into sin 2x. And we expansion of a minus b the whole square, a square minus 2ab plus b square plus 5 into d minus 5 plus 4 of sin 2x. After the simplification, e power minus x d square minus 2d plus 5d is plus 3d plus 1 plus 4 is equal to 5, 5 minus 5 cancel, so constant term not available. Therefore our PI becomes e power minus x 1 divided by d square plus 3d of sin 2x. Since d is available, our PI is not over. Now we are going to type 2. Since this is of type 2, here sin 2x available. Therefore our PI becomes e power minus x 1 by, in type 2 we replace d square, and d square is minus a square. Here a is equal to 2, so minus 2 square is minus 4. So e power minus x 1 divided by minus 4 plus 3d of sin 2x. And our PI is equal to e power minus x, denominator is minus 4 plus 3d. So we need to multiply the conjugate in numerator and denominator. Minus 4 minus 3d and minus 4 minus 3d of sin 2x in denominator of the form of a plus b into a minus b. And we know that a plus b into a minus b is a square minus b square. Therefore e power minus x, our denominator is a square minus 4 the whole square minus b square 9d the whole square. The numerator is the same, minus 4 minus 3d of sin 2x. Here in type 2, d square is equal to minus a square, here a is equal to 2, so our denominator becomes minus 4 the whole square is plus 16 minus 9 into d square by minus 4. In numerator sin 2x operate inside. So minus 4 into sin 2x minus of 3 into d of sin 2x, and that is equal to e power minus x, first in numerator, minus 4 into sin 2x minus 3 into d means d by dx, differentiation with respect to x 1 times. So differentiation of sin 2x is cos 2x into 2, that is 2 into cos 2x, and the denominator is 16, 9 into 4 36, that is e power minus x minus 4 sin 2x minus 6 cos 2x divided by 16 plus 36 is 52. So e power minus 6 divided by 52 minus 4 sin 2x minus 6 cos 2x, we take minus outside. So minus e power minus x divided by 26, 2 sin 2x plus 3 cos 2x. This is our pi. Therefore our general solution is y is equal to cf plus pi. So y is equal to a into e power minus x plus b into e power minus 4x minus e power minus x divided by 26 of 2 sin 2x plus 3 cos 2x. Hence our general solution. Thank you.